Today, we are going to tackle one of the trickier questions from a recent GCSE Physics paper. But here's the twist. We're not just going to find the right answers. Oh no, we are going to decode the exact words, the specific phrases that examiners are desperate to see, and we're going to use the official mark scheme as our secret weapon.
I mean, that's the million-dollar question, isn't it? You could be a total physics whiz, know this stuff inside and out, but if you don't phrase your answers in that very specific way, you can lose so many easy marks. So in this explainer, we are unlocking the secrets to scoring every last point by learning to think like an examiner.
Okay, let's dive right into it. Before we can even start thinking about the answers, we absolutely have to get a crystal clear picture of the scenario they've set up for us in question 9. So here's the setup. Pretty standard stuff, actually. We've got a teacher, two mystery radioactive sources, just called A and B, and a detector that's measuring the radioactivity. Now, the most important piece of evidence they give us is this graph. It shows how that count rate changes as you move the detector further away from each source. Honestly, this graph is everything.
Right. Let's get into the first part of the question, 9.1. The focus here is all on source A. And our mission, should we choose to accept it, is to use the evidence staring at us from that graph to prove it only gives off alpha radiation.
So, have a really close look at that line for source A on the graph. What's the #1 biggest giveaway property of alpha radiation that this graph just screams at you? Now remember, this question is worth 3 whole marks. That's a huge clue that we need to make 3 clear, separate points in our answer.
And here it is, the perfect 3-point answer. Literally word for word from the mark scheme. First, you get a mark just for reading the graph. The radiation travels about 3 centimeters. Easy. Second, you have to state what happens after 3 centimeters. The count rate drops right down to the background level. And that third, crucial mark is for the physics, the why. This happens because alpha radiation has a short range in air. You hit those 3 points, and you have locked in all 3 marks.
Excellent. Source A is done and dusted, so let's move on to part 9.2. Now we're looking at source B. The graph clearly shows its radiation travels much, much farther, which means it could be beta or it could be gamma. Our job is to describe a procedure to figure out which one it is.
So how do you solve this? You need an absorber. The mark scheme gives full marks for this super simple 2-step procedure. Step 1, put an aluminium sheet between the source and the detector. Step 2, see what happens. Beta radiation will be stopped dead by the aluminium, but gamma will pass right on through. What's cool is that the mark scheme also says you could use other materials, like lead or even brick. The key is just choosing something that stops beta but doesn't stop gamma.
Okay, now we get to a part of any radioactivity question that is pretty much guaranteed to show up: safety. Questions 09.3 and 09.4 are only worth 1 mark each, but they are such easy marks to grab if you're ready for them. So we're going to show you every single acceptable answer from the mark scheme.
First up, 09.3. This one's all about protecting the teacher. The main danger here is something called irradiation. That's when you're being exposed to radiation from a source that's outside your body. So what's one simple thing the teacher could do? And this just brilliantly shows you why studying the mark scheme is so powerful. Just look at this list of valid answers. Any single one of these gets you the mark. Increasing your distance, limiting your time, using tongs, wearing a lead apron. You have so many correct choices. Just pick one, write it down, and that mark is yours.
Okay, now for question 09.4. The focus is now on the students, but you've got to notice the really crucial change in the wording. We're now trying to prevent them from becoming contaminated. And that's a different thing entirely. Contamination means getting the actual radioactive material on your skin or inside your body.
And here is the official list of answers for preventing contamination. Things like wearing gloves or a lab coat or using tongs? Great answers. But also simple lab rules like no eating or drinking, or just straight up saying, do not touch the source with bare hands. And notice, use tongs is on both lists. That's because it helps prevent both irradiation and contamination. Smart, huh?
All right, it's time for the grand finale of this question, part 9.5. This is the big one, a 4-mark calculation to figure out the activity of source B at a very specific moment in time, and you have to use the graph. This is where we need to combine our graph skills with our physics knowledge.
Now this can look a little scary, I know, but the marks are broken down into really clear steps. First, you get a mark just for drawing a tangent to the curve correctly at the 300-second mark, just for drawing the line.
Second, you get another mark for trying to calculate the gradient of that tangent. Third, your final answer has to fall within an accepted range. And finally, that fourth mark, the one that is so easy to forget, is for stating the correct unit, becquerel, or BQ.
The mark scheme itself gives an example answer of 7.1 times 10 to the 20 BQ. Now, your tangent might be slightly different, so your number might be a little bit different, and that's okay. As long as your final answer is inside the examiner's accepted range, and you remember to write down the unit, you will get those final, beautiful marks.
So let's just zoom out for a second. What have we really done here? We haven't just answered a physics question, we've basically performed an autopsy on it. We've seen exactly how marks are given out for specific keywords, for graph skills, for calculations, and even just for listing one of many possible safety rules.
And that brings us to the key takeaway. Your revision is not finished just by doing practice questions. You absolutely have to look at and analyze the mark scheme too. Honestly, understanding the mark scheme is like being told the rules of the game you're about to play. It really is an exam superpower.
And on that powerful note, what topic or tricky questions should we put under the microscope next time? Let me know what you think in the comments below. Thanks for tuning in.